Okay, as we start to look at chapter 12, we're going to start to get into 3D figures. And so to start with our 3D figures, we need to be able to just identify them. We need to be able to know what kind of solid they are. Then we also need to be able to think about cross sections, and we'll get to what those are. And then also revolutions of a 2D shape, and what kind of 3D shape it will make when you revolve it around an axis. So when we have our 3D shapes, we have some different types. First of all, we're going to be talking about polyhedrons, or polyhedra. Those are whenever we have a solid that has straight edges. Okay, so it's not going to have any round spots, it's not going to have any circles, it's going to have just straight edges, and the edges, whenever they connect, okay, all the 2D parts of that image, or of that 3D shape, are what we call our faces. Okay, and so that should be a familiar term. Whenever we have edges that meet, they meet at a vertex, and so that's the point where the edges meet. And so you can see in this picture on the left side, we actually have polyhedrons. We have two polyhedrons. We have what we call a prism. A prism is whenever we have two bases, and those bases are just connected by straight edges. Those bases are going to be parallel to each other. And then we have a pyramid where it has one base, and then from the base we have lines that just come up to a point. Our non-polyhedrons are going to be the ones that have circular shapes in them. So we have a cylinder. Cylinder is whenever we have two circles that are parallel to each other. A cone, which is like a pyramid where we have a circle and then it comes up to a point. And then a sphere, obviously we know, is like a ball where it's just completely round all the way around. And so in this first example, we just want to be able to classify them. We want to know whether or not it's a polyhedron, and then be able to name these shapes as well, these 3D solids. So the first one, first you want to know, in order to know if it's a polyhedron or not, you need to see if there's anything that's circular, okay? Or do we have all straight edges? We do, so the answer to that part would be yes, it is a polyhedron. And then we need to see whether or not it has parallel bases. If it has two matching bases that are exactly the same and are parallel to each other, then are just connected by sides, or if it has one base that comes up to a point. So in this one, you can see there is no one singular point that where all the sides are brought up to. So that would mean that this one is going to be a prism. This will be a rectangular prism. But in this case, it's a prism. And like I said, once you know it's a prism, you can call it by what the base shapes are. The bases are rectangles, so that's why I said you would be a rectangular prism. In the second one, again, you want to look for, do you have all straight edges? We do, so again, it's going to be yes, it is a polyhedron. And then we want to see, do they come all to a point? Do we have one base that comes to a point, or do we have two bases that are parallel? In this case, you can see we have one base, this bottom part here, and then everything else just meets up at one point. So this one is going to be a pyramid. So we know it's a pyramid. And then again, we call it by whatever the shape is on the bottom. So the bottom, if you count how many sides it has, is 1, 2, 3, 4, 5, 6. And so with 6 sides, it means we have a hexagon. Or in this case, you add the word to it. So this is called a hexagonal prism. I think I missed an A in there actually. Hexagonal pyramid. I'm sorry, this one's not a prism. This one is a pyramid. So it is a hexagonal pyramid. The last one, do we have all straight edges? No, we have a circle, so that part's going to be no, it's not a polyhedron. But we can go ahead and classify this solid. And so if you look back, this solid is what we call a cone. Every single time we have a round base, comes up to a point, we just call this a cone. So then the next part that we look at is we're going to be talking about cross sections. You may be familiar with cross sections, like from taking biology. Sometimes you'll take a cross section of something, or you'll look at a cross section of a cell and just identify that one single little portion where it's just like a little sliver of it. Cross sections work the same way in geometry. We're just going to cut across it in a flat plane. We're going to take a plane through it, and we're going to look at what shape it makes when we take that plane across and see what shape it makes with our solid. Okay, they can be kind of tricky. It takes a lot of kind of imagining, or whether or not you need to kind of draw it out. And so just really try to think about it, try to picture it, try to draw it, do your best that you can of trying to really figure out the method that works best for you. And so in these examples that they have the plane already drawn through, and they've already shaded the spot in for you of where the plane actually meets with the 3D section. So these ones aren't too hard to identify. So in A, if we look at just the shape where it intersects, that shape is just a six-sided figure. So the intersection would just be a hexagon. For the second one of B, again, look at just the intersection. And so the intersection is that kind of purplish area. And so this one makes a triangle. For C, we have a cylinder, and we have this, again, a plane that we're just cutting through right there up and down. And so when we cut through that part, it actually makes a rectangle. Okay, a lot of times it's just making sure you're looking at where is it actually cross-sectioning it. Okay, I can do different planes on these shapes, and it's not always going to be the same shape it creates. Because if I cross-sected that cylinder the other direction instead of horizontally, or I mean vertically, if I had gone across it horizontally, if I had taken a plane across this way, the intersection there would have been a circle in the middle, right? Okay, so it just depends on where that cross section is. In D, again, you can see it, and so it makes a circle. In E, we have a sphere with this cross section, and it makes a circle. And then this last one, we have a rectangle, but we have an angled plane. Okay, a lot of these other ones, they made them very like perpendicular pretty much to the shape, or they made it parallel with the base. This one, they actually angled it, and so as you can see, it doesn't make a square, it doesn't make a rectangle. What it ends up making is a trapezoid. Because as you can see, this top part of this base is longer than this bottom part of this base. So that's what we call a trapezoid. And so then the last part that we look for this section is just revolution. Whenever we take a 2D figure and we revolve it around an axis or axes, we're going to make a 3D shape. So in this example, they take a rectangle, and if they were to revolve it around that axis, okay, and you were able to see the shape it would make, it's going to make a cylinder. And so you kind of have to think about, especially if you were to rotate, like if you had a flag or something connected to, if I give you like one of those little flags that you can just hold, a lot of times like 4th of July, they'll have flags everywhere. And if you were to spin it really fast, you kind of see how that flag around that, whatever the stick is, the pole that you're holding, would end up making a cylinder, especially if you were to take like a piece of paper and just tape it on there and you spin it really fast. It starts to look like a cylinder because of how fast you're spinning it. Your eye can't actually see just the one spot that it's in. And so in this example 3, we're going to try to kind of sketch the solid, and then we're going to identify it, and we're going to try to just describe it a little bit. So in this one, if we want to rotate, we have a rectangle again, we're rotating it around this axis. What's going to happen is at this point, okay, if I take this vertex here, when I rotate it around, it's going to rotate around in a circle. Same thing would happen on this point as well, right? It would rotate around in a circle. And then if I were to connect them, okay, it's going to make that cylinder again, just like last time. Now, obviously, my picture is not beautiful by any means. Certainly not like theirs is, being able to draw it. If you want to be able to do the dotted lines showing where in the back here, especially this one would be like dotted. Okay, because it would be in the background where you can't see it as much. And so when we do this, this makes a cylinder. Okay, right, because it's going to be round bases. Okay, they're going to be parallel bases to each other. And the cylinder, the circles are going to have a radius of 4. They're going to have a diameter of 8. So if you wanted to say that part, you could describe it that way. You would say that the height of that cylinder is going to be 9. And so those are some of the ways that you can describe it. There's many different ways that you could go about that. Mainly, you need to be able to identify the shape. In the second one, again, if we want to rotate this part around, it's going to rotate around in a circle. Okay, and if you want to do the back part of it where it's more a dotted line, so that way it seems more 3D. This part, though, is just going to stay right there, right? It doesn't rotate because it's already on the line. And so it would just connect all the way down. We'd have this triangle going all the way around. And so it's going to make a cone. And again, if we look at the circle in the bottom of the cone, the base of the cone would have a radius of 2. It would have a diameter of 4. And in this cone would have a height of 5. And so that's all that we're basically looking at in this section. We're going to get to looking at surface area of these shapes. We're going to be looking at volume of these shapes. And that's going to be the primary part that we look at throughout chapter 12.